Hello YouTube. Today we're going to focus on the quotient rule. Yesterday we did the product rule. And so let's see if we can prove the quotient rule. Let's derive it. So if phi of x, I ran out of letters, so I'm going to call it phi of x, is f of x divided by g of x, then phi prime, or d phi dx, is low d high minus high d low all over low skirts. Remember, we had a little song on YouTube for this. All right, and so let's prove it. So phi prime is the limit as h goes to 0 of phi of x plus h. In other words, just plug in x plus h into f of x over g of x. So f of x plus h over g of x plus h. Okay. Minus phi of x itself, which is f of x over g of x. And this is all over h for the difference quotient. Definition of the derivative as the limit for delta x or h going to 0. All right, so now this, I don't recognize any of this. Remember last time when we did the product rule, we finagled it so we could see f of x plus h minus f of x all over h somewhere, and g of x plus h minus g of x over h somewhere. I don't got that yet. So here's the plan. How about if we just add those two fractions you see in the numerator? You need a common denominator. So what we did was we multiplied the first fraction by g of x over g of x. So g of x on top and g of x on the bottom. So we could get the same common denominator in both fractions of g of x times g of x plus h. So minus, let's multiply the second fraction, numerator and denominator, by g of x plus h. So f of x times g of x plus h and g of x times f of x, g of x plus h. So the common denominator is g of x times g of x plus h. Okay, good. Now, don't forget, how do you divide by h? Well, it's really h over 1, so how do you divide by that? You multiply by the reciprocal. So how about we do 2 steps in 1? Can we handle it? Can you handle the math? All right, there you go. So subtract. All right, so how do you subtract two fractions with the same denominator? You keep the denominator and add the fractions. Okay, so I'm going to write, or subtract the fractions. G of x times f of x plus h minus, let's leave a little gap here, f of x times g of x plus h, that's the numerator, over the common denominator of g of x times g of x plus h. Now don't forget, we're multiplying that by 1 over h. The numerator times 1 doesn't change, the denominator times h. Just put the h down there. Okay. Now I left a little blank here because what Newton said was, okay, we can prove this if we add 0, sort of like we did with the product rule. But this is what he came up with. He said, what if I add f of x plus g of x times g of x? Is that adding 0? No. We have to subtract it away. Now, did I add 0? Yeah. But why did he pick this combination? Because look at the first two terms in the numerator. Isn't there a common factor of g of x? So if you factor out g of x in the first two terms, you're left with f of x plus h minus f of x. And it's over h, isn't it? Okay. Okay. And then in the last two terms, the third and the fourth terms of the numerator, can you factor out an f of x? So plus f of x times, what do you get? What's that? G of x minus g of x plus h all over h, right? And don't forget, it's all over still this common denominator of g of x times g of x plus h. Okay. Now, wait a minute. So as h goes to 0, g of x goes to g of x because there's no h there. But f of x plus h minus f of x over h is what as h goes to 0? That's f prime. As h goes to 0, what happens to f of x? Nothing. There's no h there. Okay, so leave it. As h goes to 0, what does this go to? And don't say g prime. Do you see that it's not g prime? Isn't it backwards? Shouldn't it say g of x plus h minus g of x all over h? So if I write it backwards, what's the only thing that happens if you change the order of a subtraction problem, of a difference? You change the sign, right? So if I say that's negative g prime, is that right? Yeah, it is. And then what's the limit as h goes to 0 of this? Well, it's g of x because there's no h in there. And what's the limit as h goes to 0 of this? Well, x plus 0 is x, so you get g of x. So guess what you got? In the limit, as h goes to 0, you get g of x times f prime plus f of x times a negative g of x. How about minus f of x times g prime of x? Over g of x times g of x. How about g of x squared? And isn't that what we said? G f prime minus f g prime over g squared. G f prime minus f g prime over g squared. Okay, good. So let's practice that up. How do you work with the quotient rule? Yesterday we worked with the product rule. Here's a quotient rule question. All right, so y equals x squared minus 1 over x squared plus 1, let's say, right? All right, so what's dy dx? All right, so here we go. So we found a song on YouTube. It goes, low d high minus high d low all over low squared. Right? So if x squared minus 1 is f and x squared plus 1 is g, the high function is f, x squared minus 1, and the low function is g, x squared plus 1. So low, just copy it. D high, differentiate the top. Low d high minus high, just copy it. D low, just differentiate the bottom. All over low squared. There you go. Perfect. All right, so we could simplify this. Let's see. 2x times x squared plus 1 distributed. You get 2x cubed plus 2x. Quantity minus, let's distribute the 2x over in the second term. 2x times x squared minus 1 is 2x cubed minus 2x. All over x squared plus 1 all squared. Okay, we can simplify that some more even. Because remember, how do you subtract? In the numerator, we got to subtract. You never do, right? So, add the opposite. So what are we adding? 2x cubed plus the opposite of 2x cubed, that cancels. And 2x plus the opposite of negative 2x is 2x plus 2x is 4x. So you get 4x over x squared plus 1 squared. Now remember the product rule yesterday, we checked it by foiling it out and just differentiating a polynomial. We can't do that here because you can't FOIL out. So how are you going to check this? You can check this in the calculator. What if I made this y1? And then let's graph the calculator's derivative, the math 8 key in y2. And let's make this y3 and see if they match. Okay, let's do that. All right, where's my calculating device? Is it on? No. Come on, calculator. We're doing a normal and a tangent line problem. All right, so the normal and tangent to y equals x plus 2 over x using the quotient rule. All right, but let's check the quotient rule problem we have right now. It's different. I'm just looking at the homework. All right, let's get a big screen. All right, so let's put in alpha y equals enter into y1 the original problem, which was x squared minus 1 over x squared plus 1. And now, I don't want to graph that, so I'm going to turn off the equal sign. Come on. Come on. Wow, this takes all day to get over here. Okay, turn that off. What I want to graph is the derivative of that. So, math, what? 8. And in this class, you always put an x here. We'll talk about that in Calc 3 when it's not an x there. All right, and this is going to be y1. Vars, y vars, function 1, unless you want to retype x squared minus 1 over x squared plus 1. And what we're going to put here is where we want to take the derivative. What I'm going to do, usually you put a number here, right, on the home screen. So you can get y prime at 2 or something. I'm going to put x here. What does that mean? For every single pixel on the screen, whatever that x value is, let's find the derivative there and graph that. All right, so let's see what that is. I'm not graphing y1, I'm just graphing y2. Zoom 4. So here's y2, the derivative function according to the calculator. It's actually calculating the slope of every single tangent line you can graph on the original function y1, and then graphing those slopes as the y values of y2, the derivative. And there you go. Now, let's check our answer. What was our answer? Let's see if it's the same. It should overlap if it's the same, right? So we had rational, what, 4x over quantity x squared plus 1 all squared. Didn't we? Yes, we did. So if we're right, the red curve should turn into black, the black curve, because the black curve is going to overlap. Here we go. And no. What happened? Did I type something wrong? That's wrong. Hang on. Wait, I think I typed something wrong. I didn't. Oh, did I square? I want to square the denominator in here. I thought I squared. What happened? Square the whole thing. There you go. All right. So here's the red curve regraphed. The derivative according to the calculator. This is math 8 for every single point along y1. This is y2. And then y3 should overlap it. y3 was black, so let's see if the black curve overlaps the red curve. And boom, there it is. At least on this window or this domain, it is correct, right? Now, why does it look like that? Okay, let me turn off y3 from here. I just want one of these derivatives. I don't need it to be overlapping. And I want to compare it to the original function. So is there a relationship between the graph of the derivative and the graph of the function of that, the derivative of that function? So here's the function we're differentiating. And here's the derivative. So look at the y values. Aren't the y values right now negative? Why? Why are they negative? Then 0, then positive. Do you see the y values of y prime? This is y3 is y prime. Are negative and positive. Okay. So pretend in the second quadrant, if you graph a tangent line along the blue curve, isn't it always going to be negative? In other words, the blue curve is decreasing. So when the derivative is negative, the curve is decreasing, the function is decreasing. Isn't that what the red values are? The y values of the red curve are those negative numbers, the slopes of the tangent lines, anywhere along the blue curve. Okay. And then in the first quadrant, notice that the red curve has always got positive y values. Why? Because imagine graphing tangent lines along the blue curve anywhere where x is greater than 0. Aren't they all going to have positive slopes? That's what it's graphing, the slope of every single tangent line along the blue curve. Do you see anywhere where you could draw a tangent line that's horizontal to the blue curve? Yeah, look, at x equals 1. At x equals 0. The slope is 0. All right, that's why the red curve has a y value of 0 when x is 0. And so that's the first derivative test. If you're trying to minimize a function, look where the derivative changes sign from negative to 0 to positive, or negative to undefined to positive. In other words, where it changes sign from negative to positive. And by the way, you can find a max, like a frown parabola, where the derivative changes sign from positive to negative. So the first derivative test says look for this change in sign, SIGN, of the derivative to find mins and maxes. All right, so that's it for today. And that should help you do your homework, which is the same sheet as last night. Page 124 by multiples of 5 today. Okay? All right, bye-bye. Hope that was helpful. See you, YouTube.